I am Dr.J.Maria Felicit, Assistant Professor, Department of Mathematics, Bishop Heber College. The title is Sequence of Real Numbers. First, we will see to the real numbers. What are real numbers? So, real numbers are from this minus infinity to plus infinity. That is minus 1, minus 2, minus 3, 0, 1, 2 and 3, etc. So, we define the real numbers to be in the real line of minus infinity to plus infinity. Then we will see to the basic definition of sequences. The sequence is a ordered list of numbers. It may be of 1, so it may be of the sequence 1, 2, 3, 4, etc. That is n. So we are taking this to be in the real line of R, that is from minus infinity to plus infinity. So in mathematics, the sequence we defined as a function of sequences. The sequence is a function whose domain is a set of natural numbers and whose range is set in the subset of R as a sequence of real sequences. If you take the range set in the complex plane, it is said to be a complex sequences. If you take this range of the subset of R to be in the polynomial, then it is said to be a polynomial sequences. Generally, the sequence is denoted as an, such as this an can be written as a1, a2, a3, etc. So, the sequence may be of from the natural numbers to the set of real numbers. So, we know that the natural number, the definition of natural number is whenever we define the natural numbers as to be like this, that is when we are taking the real number r. If I am taking a number to be n such that it is a set of all natural numbers, the next number will be of n plus 1, that will be in the real number r. So similarly, if you move to next number, that is n plus 2, it will be in the real number of r. So this is the definition of set of all natural numbers. So we are going to take the function of sequences to be in the natural numbers and the domain in the subset of the range, that is to be in r. So this is said to be the real sequences. So sequences may be of real sequences, complex sequences, polynomial sequences. And if you take the sequence an to be 5, that is a number, a constant, it will be of a constant sequences. So Fibonacci series also is there. So next we will see to move to bounded above and bounded below sequences. So what do you mean by bounded sequence? So if I am going to take a sequence an, then it is said to be a bounded sequence. We are going to take a bounded sequence of an in the real line, not in any other line. So we are going to see the sequence in the real line. If I am taking a number in the real line, that is, let us take u. So u belongs to the real number r, such that for this sequence, the upper bound is u. So I am going to compare this upper bound for an, the sequence. So sequence, if the sequence an is less than or equal to u, then u is said to be the upper bound. If I am going to take another number, suppose m1, so which is an is less than or equal to m1, this is the upper bound, then the upper bound is m1 for the real sequences. So next, the sequence of a bounded below sequence. So once again, the sequence an is said to be bounded below. If I am going to take the sequence in the real line an, and there exists an element L in the real line R, then it should be like this. An should be less than or equal to, that is, L should be less than or equal to an, or an should be greater than or equal to n. So here the n is a set of all natural numbers. So then L is called the lower bound of the sequence. If it is less than an, then it is said to be a lower bound. If it is greater than, it is said to be a upper bound. So the upper bound is also said to be a bounded above, and the lower bound is said to be the bounded below functions. So the sequence is said to be a bounded sequence when it is said to be a bounded sequence, if it is bounded above as well as bounded below. So we can denote this notation as L is less than or equal to an, less than or equal to u, where here it is a lower, L is the lower bound and u is the upper bound. For this sequence, I am saying that this is the lower bound and the upper bound. We can take whatever the sequence. If you want a1 to be the sequence and another one upper bound, if you are taking m1 or m2, whatever it may be, it is said to be the bounded above function. And if you are taking L2, L3, whatever it may be, it can be a lower bound for the sequences. So when you say this to be a unbounded sequence, a sequence an is said to be a unbounded sequence if it is not a bounded sequence. So bounded sequence, what do you say? It may be a lower bound or it may be a upper bound. But if it is not a lower bound or not a upper bound, if you are having like this a sequence, if this is a sequence, so if this is a sequence of, I'm going to take a sequence an. If I'm going to take a number 1, that is minus 1, let us take it as minus 1, and plus 1 is a limit. So I'm going to take it in the closed interval of minus 1 to 1 in the real number of r. Okay. So if it is, this is also a lower bound for the sequence of an. This is also an upper bound of the sequence an. So which is the lower bound here? Minus 1 is a lower bound and 1 is the upper bound of the sequence an. If this is, these are all the lower bounds of the sequence, these are all the upper bounds of the sequence. So if it is bounded, if it is not here, if I am marking this area, suppose I am marking in this area, then it is said to be a unbounded sequences. So it may be bounded above or bounded below, but if it is not in this range, if it is in between minus 1 to 1, then it is said to be a unbounded sequences. So next we are going to see is a supremum and infimum of a set. So I am going to take a set A in the real number R, such that if I am going to take a number in the real line such that M is the upper bound of that set A, such that if whatever upper bound M1, M2, M3, M4, whatever I am taking as upper bound, it will be the upper bound for the sequence, but the least upper bound will be the M. So M1 I am taking in this green line M1, M2, M3, M4, M5, whatever I am taking, these are all the upper bounds, but the least upper bound is the M. So we will say the least upper bound as the supremum, and the next one is the greatest, that is infimum we are going to define. So infimum, I am going to take the lower bound as small m for this sequence, and m small m1, m2, m3, m4, whatever I am taking, these are all the lower bounds of the sequence an, but the greatest lower bound is the m small m. So it is said to be infimum. So the least upper bound is the supremum and the greatest lower bound is the upper bound. So you can say, you can ask that why we are using this in the real line. So every mathematics will use this in the real line of the sequences. So the real line, the basic of mathematics is the real number and the set of all natural numbers. So this is the concept of that is upper bound and the lower bound of the sequence. Thank you.